Okay, good morning. We're going to look at section 8.4 today. And when you get done looking at the notes, then you can have time to work on the homework in class. We're going to start with Pascal's triangle. And I'm going to draw it out for you. And then we're going to look at some patterns that happen with it. So Pascal's triangle is going to start with a 1 at the top, and then it'll be two 1s, and then a 1, a 2, and a 1, and then a 1, 3, 3, 1. Okay, so I'm going to stop right there. You're going to notice that there's always going to be 1s along both of the sides. And then what you should see is if you add any two numbers, like the 1 and the 1, they make this 2. Or 1 and the 2 make that 3. Or the 2 and the 1 make that 3. So if we keep following that pattern, what will the next row be? So it's always going to be a 1 out on the edge. Then we're going to do 1 plus 3 and get 4. Then 3 plus 3 and get 6. 3 plus 1 and get 4. And then another 1 on the edge there. Okay, and this would just continue on forever. So now what would be the next row? So it'll be a 1, 5, 10, 10, 5, and a 1. And there are a lot of patterns happening in Pascal's triangle, a lot of really cool things to observe. Do you notice how this goes 1, 2, 3, 4, 5, or it can go this way, 1, 2, 3, 4, 5. There's symmetry. So as you read left to right, it goes up and then back down again. 1, 4, 6, 4, 1, there's symmetry. 1, 5, 10, 10, 5, 1 is symmetry. So just kind of keep that in mind. Here's another view of Pascal's triangle. The thing that you need to remember is that when we start counting with rows or even start counting terms, we always start at 0. So this 1 way up here is just the 0th row. Then we have our first row. Then we have our second row, which it's going to help you. I'm going to get a different color. It's going to help you to see that the second row has a 2, and then the third row has a 3, and the fourth row has a 4, and the fifth row has a 5, etc. Here's the first row. So you see how this would be the 0th row if you want to think of it that way. Also start counting your terms at 0. So for example, this circled 10 right here, this is in the 5th row. It's in the 5th row. My pen is a little bit not the best. Okay, 5th row, and it is not the 3rd term because we start counting with 0. So this would be the 0 term, 1st term, 2nd term. So this is in the 5th row, and it's the 2nd term. Just remember to always start counting with 0. And I have that up here. Okay. So now I want you to just take a look at these. These are called binomial expansions. And I want you to look at how these binomials, if we were to take this a plus b and raise it to the 0 power, we would get a 1 because anything to the 0 power is 1. If we had a plus b and we raised it to the first, it would just be a plus b. If you took a plus b squared, wrote it out twice, and FOILed it, you would get this. If you took a plus b, wrote it out 3 times, and FOILed, you would get this, okay? So these are called binomial expansions. But what I want you to do is look for patterns. okay? And I'm going to try to do maybe some highlighting, see if that'll work. So I want you to try to figure out what's going on with this n value, and I want to know what does the n correspond to. So just kind of look, 0, 1, 2, 3, 4, 5. And hopefully that you make the connection that that n represents the row that you're in, the row number. So I need to get a pen. My board is just very, very slow, so you might want to put this at like 1.5 speed. Okay, then the next question is, where do the coefficients come from? So the coefficients are the numbers in front of each variable. So the coefficient here is a 1 and a 1. Here's a 1, 2, 1, 1, 3, 3, 1. Okay, you might be starting to see the pattern. 1, 4, 6, 4, 1. Okay, and then we've got 1, 5, 10, 10, 5, 1. So my question is, where are those coefficients coming from? Where would we get those numbers from? And hopefully you're recognizing the pattern from Pascal's triangle. 1, 5, 10, 10, 5, 1, 1, 4, 6, 4, 1. Okay, go back and look here. See how all these red numbers are from Pascal's triangle. Okay, the next thing I want you to do is look at the exponents on the A's and the B's. So I want you to see if you see a pattern happening on the exponents. So let's start by looking at the exponents of the A's. And I'll see if I can highlight them. So for example, let's start here because we'll be able to see it better. So we've got a 5, then a 4, then a 3, then a 2, then that would technically be a 1, right? And then the A is gone here, so that would be an A to the 0. Same thing here, so we go 4, 3, 2, that would be a 1. 3, 2, 1. And when the A's are gone, it's like it's an A to the 0. So 2, 1. So what's happening with these exponents of the A's? Okay, they are decreasing. Oops, I need to get my pen. Okay, so the A's exponents are decreasing. And they start with whatever this n value is. So that's your starting exponent. Okay, you see that? And then they decrease every term, they decrease. Okay, now what's happening with the B exponents? All right, so the B exponents, well, there aren't any B's first, so that would mean like a B to the 0. So this we have like a B to the 0. This is a B to the first, B squared, B third, B to the fourth, B to the fifth. Or here, this is a B to the 0, B to the first, B squared, B to the third, B to the fourth. So you might be able to see that the B exponents are increasing. Okay, so I'm going to write that down here. here. So the b exponents are increasing. Oops. You get the idea. Okay, so basically what we're going to do is take anything to a power, any binomial. Binomial has two terms. So anything with two terms, raise it to a power. And instead of writing it out 5 times and FOIL, 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 we're going to use this pattern to expand it. It's really, really cool. Very slick. Okay, so here's our first example. We have a plus b to the 7th. So I do not want to write that out 7 times and FOIL it a ton. So what I'm going to use is my pattern that we found on this last page. So remember, what does I'm going to highlight it here. What does this number do again? Okay, that tells us what row we're in. Okay, so we're going to be in the 7th row. So what you would want to do is go back to Pascal's triangle and look at the 7th row. So 0, 1, 2, 3, 4. This would be the 5th row. This would be the 6th row. This is the 7th row down here. Pen. 7th row. Okay, so you're going to take these numbers that are in the 7th row, and these are going to be your coefficients. So looking back, okay, remember these red numbers, the 1, 5, 10, 10, 5, 1. Those are the coefficients in whatever this row is. So we need to be in the 7th row. These are our coefficients, 1, 7, 21, 35, 35, 21, 7, 1. So what I'm going to do is start setting this up. So it goes 1, 7, 21, 35, 35, 21, 7, and 1. Okay, and there's going to be plus signs in front of each of them. These are going to be the coefficients for the next terms. Okay, pause here just a second. My son is at the table with me. You need to eat more breakfast. Yeah, get like cereal or something. Okay. Okay, so we have our coefficients written out. Let's just make sure it was right. 1, 7, 21, 35, 35, 21, 7, 1. Okay, there's the coefficients. Now the next thing is we need to look at what's going on with our first thing in the binomial, which is an a. So going back here, remember how we said that the a's decrease their exponents? So it's going to start with the highest exponent. Whatever row you're in, it's going to start with that as the exponent, and then it's going to decrease. The a's decrease. Okay, so then this is going to be an a to the 7th, because this is a 7. And then it's going to decrease. So a to the 6th, a to the 5th, a to the 4th, a to the 3rd, a squared, a to the 1st, and then this would technically be a to the 0, which you wouldn't have to write because a to the 0 is just a 1. Okay, and then now we have to look at what's happening with the b's. So if we go back here, the b's are increasing. So the b term is going to start to the 0 power, and then it's going to work its way up. And the highest it goes is whatever that exponent was. So the b is going to start with a 0 exponent, and then b to the 1st, b squared, and so on. Okay, so that really doesn't need any more simplifying. I mean, we technically would not need to write the b to the 0 or the a to the 0. So if I was going to write this, just slightly simplified, it would be a to the 7th plus 7a to the 6th b plus 21a to the 5th b squared plus 35 a to the 4th b to the 3rd plus 35 a to the 3rd b to the 4th plus 21 a to the 2nd b to the 5th plus 7a b to the 6th plus b to the 7th. Okay, and that would be your answer. Nothing, it has like terms, so there's nothing to combine. So that would be your binomial expansion. So had we written out a plus b to the 7th power 7 times, or just if we had written a plus b times a plus b times a times, you get what I'm saying. If we, it's too early in the morning. Okay, so if we had written this out a whole bunch of times, 7 times, and then FOILed it a whole bunch, this is what we would have gotten. So this method is way faster. Pascal's triangle is really cool. You should look it up. Google it. There's so many cool patterns. Okay, next one we're going to try is this x squared plus 4 to the 3rd. Okay, so again, that 3 represents what row we need. So in this case, we need the 3rd row. So we're going to go back and look at Pascal's triangle. We're going to look at the 3rd row, and those are the coefficients we need. So these are the coefficients we're going to use. 1, 3, 3, 1. So I always just get them written out. 1 plus 3 plus 3 plus 1. Okay. Now the next thing is, remember when I circled the a? Now I'm going to circle the x squared. So this is changing just a little bit. Instead of just an a to a power, in this problem it's going to be an x squared to a power. So we're going to be taking x squared, and remember what the a's did? They went from 7, 6, 5, 4, 3, 2. They decreased. They started with this highest value. So it's going to decrease. It's going to start with the highest exponent of 3 because this highlighted number here is a 3. So then the next one will be an x squared, and the exponent will decrease to a 2. And then the next one will be an x squared, and the exponent will decrease to a 1. And then it'll be an x squared, and the exponent will decrease to a 0. And then, just like we did with the b, we're going to take the 4, and the exponents on that are going to increase. Remember up here, the b's went 0, 1, 2, 3, 4, 5, all the way up to 7. So now it's not a b, it's a 4, and it is going to start at 0, and it's going to increase. So the next one will be 4 to the 1st, and then the next one will be 4 squared, and then the next one will be 4 to the 3rd. Oops, I meant to have parentheses right there. Okay, now we do need to do some simplifying now. So x squared to the 3rd is x to the 6th. 4 to the 0 is 1, 1 times 1 is 1. I don't need to really write that. Okay, x squared squared is x to the 4th. And then we have 3 times 4 to the 1st. 3 times 4 to the 1st is 12. And again, x squared squared is x to the 4th. Okay, and then this next one, we have x squared to the 1st, which is just x squared. But then we have 4 squared times 3. So that would be 16 times 3. And that's 48. So then we have 48x squared. Okay, and then this last one, x squared to the 0 is 1, so 1 times 1, and then we have 4 to the third. So 4 to the third is 64. Okay, so this black stuff down here is the simplified version. If we had taken this original thing, wrote it out 3 times and foiled it a whole bunch, this is what we would get right here. Okay, I think we maybe have one more example. This will be our last example. Now the thing to be aware of is this negative sign here. We haven't had that in any of our examples so far. They've both been pluses. So you're going to see that this negative is going to be responsible for alternating positive and negative signs. What I'm going to suggest is, like, remember when we circled the 4 or we circled the b? You're going to circle the negative 2y. You're going to circle the negative with it so that you remember to raise that negative to a power, and that's going to change the signs alternating. You're going to hear some noises right now, and that's my kids getting breakfast. Okay, so here our exponent is a 4. So that means that we are going to be in the 4th row. So you're going to go to Pascal's triangle, and you're going to look at the coefficients in the 4th row. So if we go back, coefficients in the 4th row are 1, 4, 6, 4, 1. So I'm going to get those ready. 1, 4, 6, 4, 1. Okay. And I want to keep my color coding the same, so I use green first. Okay. So I'm going to circle the x. And remember, that is going to start with the highest exponent, and then it's going to decrease. So it's going to start as an x to the 4th, then it's going to decrease to an x to the 3rd, decrease to x squared, decrease to x to the 1st, and then this would be x to the 0, which you do not need to write because it's just 1. All right, now here's where the difference comes in. So now I'm going to make sure that I take that negative with the 2y. And it's really important to write with parentheses. So we're taking that negative 2y, and it starts with a 0 exponent, and it's going to increase. So negative 2y to the 1st, negative 2y squared, negative 2y to the 3rd, and negative 2y to the 4th. Okay, now some of you guys think that parentheses are not that important, but they really are. If you don't put parentheses around those negative 2y's, you're not going to be raising that negative to a power correctly. And you might even forget to raise both the negative 2 and the y to the power. So you have to be very careful here when we're simplifying. So here we have an x to the 4th, and then anything to the 0 power is 1. So this whole red thing is just a 1. 1 times 1 is 1. I don't need to rewrite that. Okay, next we've got negative 2 to the 1st power, which is a negative 2. And negative 2 times 4 is a negative 8. And then we have an x to the 3rd. And then we have a y to the 1st. Okay, next up, we've got a negative 2 squared, which is a positive 4. 4 times 6 is 24. We have an x squared, and then this would be a y squared. All right, the next one, negative 2 to the 3rd is a negative 8. Negative 8 times 4, we get a negative 32. We have an x to the 1st, which is just an x. And then we have a y to the 3rd. And then next up, we've got a 1, x to the 0 is another 1, and then negative 2 to the 4th. So we get a 16, a positive 16, and then y to the 4th. Okay, and these plus negatives, let's fix that. Let's clean that up. I'm just going to change that plus a negative to a minus. And I'm going to do the same thing over here. I'm going to change this plus a negative to a minus. And then now you can see a little bit better that alternating positive, negative, positive, negative, positive pattern. And you get that whenever you've got a minus right there. Because again, you're taking a negative number to a power, and that's going to make the alternating signs. So please remember, on a problem like this, for example, over here, that is negative 2 squared and it's y squared. So negative 2 squared was 4. 4 times 6, that's how we got the 24. Over here, remember, it's negative 2 to the third and y to the third. So negative 2 to the third was a negative 8 times 4. That gave us the negative 32. Okay, so your homework tonight is 8.4, day 1. And it is all of this same stuff. Okay, so now work on the homework. I will see you on Thursday, block day. Okay, bye.